Hi everybody, this is Marzieh Babaeianjelodar, and I'm going to talk to you about quantifying gender bias in different corpora. We are from Clarkson University from the Computer Science Department. My co-authors are Josh Gordon, Stephen Lorenz, Jeanna Matthews, and Evan Freitag. And this is our email addresses. Feel free to contact us, and if you have any questions regarding our research, we would be happy to answer you. We would be happy to discuss it with you. This is the overview of what I'm going to talk about in this presentation. I'm going to start with the introduction, and I'm going to talk to you about the key findings, and then I'm going to break it down to the background with the word embedding itself, and talk about the data sets, and I'm going to go further to the methodology part, talk about the pre-trained model, the fine-tuned part, and then talk about how we calculate the gender bias, and conclude our research work with the results. Introduction. Machine learning algorithms are being used in different applications. Wording embedding models are effective in performing a variety of NLP tasks, such as parsing resumes. And for example, the AIs that parse resumes for a job candidate to get that position, if that AI is biased against women, what would happen? Who would get hired? It will be most likely that men would get hired for that specific position, for example, a computer scientist or a computer programmer. Another example would be translating a document from one language to another. What if one language has gender pronouns and the other one doesn't? How would that get translated? Another example is identifying audiences for web advertisement. If that group is female or if it's male, what type of advertisement they should be exposed to. The impact of algorithms or specifically machine learning algorithms in decision-making systems is really high. For example, in hiring, housing, credit, Buluk-Bassi et al. Showed that Google News trained with Word2Vec displayed a disturbing level of gender bias. And they also explained further that the profession computer programmer was associated with men and the profession homemaker was associated with women. If this type of AI is used in parsing resume, what would that result into? That would be really problematic, and it would most likely hire men compared to women. And this is the issue that we are basically worried about. This is the machine learning models that are making important decisions and they're not being evaluated beforehand. And we are not basically saying not to use these AIs. We're basically saying before using them, what are these consisting of? Are they ingredients that are untrustworthy? And mostly they are. The ingredients are untrustworthy. And before using them, we need to evaluate them. We need to test and see if we can use them for the critical decision-making systems. At last, here, I want to talk about the key findings before going into the background and breaking it up further. I want to talk about the results of our work, and I want to talk about the steps that we got these results after this. The important key finding that we came into in this research is that gender bias in different corpora is unintuitive for humans to predict. As an example here, you can see that on the leftmost bar, we have this pre-trained model. This bar chart is showing the different gender bias in different trained data sets on a pre-trained model. And you can see that the base has a line, a dashed white line that is on top of each of these bars and showing the comparison between the base and other fine-tuned or further fine-tuned trained models. So as an example, you can see that these black ones are higher than the base model, and the black bars are the glue or the common linguistic benchmarks that we've used here, and they are higher than the base model or even the identity toxic model. And if I ask you, would a common linguistic benchmark show more gender bias or toxic data set that is toxic against gender and like religion, and so on, you would probably say the toxic one. But surprisingly, in our research, it shows that the linguistic ones showed more gender bias. And that's unexpected, and that shows that gender bias in different corpora is unintuitive for the humans to predict. And also, on the rightmost bar, you can see that there's this star patterned bar, and that one is the RT gender. It's labeled based on female and male, and that one shows higher gender bias compared to the other bars. That is completely expected. It's labeled based on female and male posts, or the basically the gender of the person who is writing that post on social media and so on. And this is our key finding, and I'm going to further break it down. I'm going to further talk about the background methodology of our work and give you a table of our results. Background. What are word embeddings? Word embeddings are representation of words in a vector space. Each word is a word vector. The distances between the words are basically the distances between the vectors are the relationship between the words. Word embeddings can answer analogies such as the word man is to the word woman, as the word king is to the word which word, and the word embedding spits out queen. Also, word embeddings can predict the previous word and the future word. Word2Vec is one type of word embedding. It's a shallow neural network with 3 layers, one hidden layer. It's context-free and unidirectional, as opposed to BERT, which is based on a deeper multi-layered neural network than Word2Vec, and it's both contextual and bidirectional. It is able to produce a richer model because of all those features. By bidirectional, I mean it can predict the previous and next words. By contextual, we mean each word is represented based on other words, and it's published by Google AI. We're using BERT in this research. It's pre-trained, so we are basically pre-trained models are commonly used, and a lot of researchers are getting these big pre-trained models and fine-tuning with smaller data sets. And some of these tasks that are fine-tuned after, I'm going to explain them in more detail further. So instead of getting data from scratch, they're basically getting a big pre-trained model, fine-tuning on smaller data sets. And there are some issues here with training from scratch. So you can get a lot of data, you can get large data sets, and those can provide you the opportunity to learn a lot when you have a lot of data. The issue is that they are computationally expensive to process and acquire. And another important thing to take into account is labeling corpora. For example, if you're labeling it based on the political aspect, you have to be familiar with the political landscape of the time and the place being examined. And we're studying these pre-trained models, like basically we're using them. And that brings us to this stage that we're studying the ingredients from elsewhere in the new context without much visibility of where these biases come from exactly. General language understanding evaluation is the data set, is one of the data sets that we've been using to fine tune. So basically it's called GLUE, and it covers different data set sizes. It covers a lot of text genres. You can see in this table I brought, and I put it here for you to see the domain of these different tasks. For example, fiction books, Wikipedia, online news sources, there are different domains. They have different types. Most of them have 2 classes, but one of them has 3 classes, and there are different tasks to paraphrase. If one phrase is a paraphrase of another, English acceptability, if it's grammatically correct or not, and different tasks. It's like WNLI, COLA, and SST2, and QQP. So for example, QQP comes from Quora, question answering, and RTE is the online news sources, and QNLI comes from Wikipedia. An important thing about picking GLUE is that it's an example of high quality pre-labeled set for fine-tuning to compare with toxic and RT gender. And our results are very surprising to us because GLUE showed higher gender bias compared to a data set like toxic, and that was really surprising. And that's why we need to quantify gender bias in different data sets before using them, even before using the model itself. And BERT has been shown to offer high performance and high average accuracy on these glue tasks. So that's why we basically picked glue. And moving further to the other two data sets. One is the jigsaw toxicity data set, which contains of labeled data basically of toxic and not toxic. And by toxic, I mean it's a set of negative online behaviors such as toxic comments that are biased against race, religion, disability, gender, and it's obtained from Kaggle. It's not in the glue benchmark, and this task basically says if this comment is toxic or not. RT gender, on the other hand, is labeled based on F and M, which means female and male, and specifically it's the comments or the author, the gender of the author of the comment to that online post that is like toxic or gender based, like basically if that gender is female or if that gender is male. That RT gender data set includes response to Facebook, posts from U.S. House, Senate, public figures such as TV hosts and athletics. It also includes responses to TED speakers and so on. And you can see here in the table, I have the corpuses or the corpora, toxic and RT gender, identity-based biases and gender-based biases, their type and their domain, which is different, but the type is for both two classes. Methodology. First, we got this BERT's pre-trained model, and we fine-tuned upon that. And this BERT's pre-trained model that we obtained was 12 layers, and it consists of 2,500 million words in Wikipedia and 800 million words in book corpus. So when we were fine-tuning, we were fine-tuning on those datasets that I have explained, and we extracted the word vectors from all those datasets to calculate the direct bias. To calculate the direct bias, we first got the G direction. So for the direct bias calculation, I have to mention that we got this methodology from the Babaeianjelodar et al. Paper, and there isn't anything new that we did, but we followed their method, and we basically started with getting those 10 pairs or 10 gender pairs, and it was like she, he, her, his, woman, man, etc. And the profession words were like 320 supposedly neutral profession words, like accountant, like doctor, like inventor, and those were obtained. And then we got the center of these gender pairs. We subtracted each one of those words inside that gender pairs from the center, and we ran PCA on it. And then we got the first eigenvalue, which shows the which is the highest, and it shows that the most data is inside that part. So that is the G direction. And so we got the G direction, we have the ingredients here, so we can calculate the direct bias based on that. And this is how we did it. We used this formula from the Babaeianjelodar et al. Paper, and we calculate the direct bias based on it. So N represents the neutral words, G represents the G direction, C is the strictness of the bias. That could be manipulated, that could be changed, but we stuck with C equals to 1, just like Babaeianjelodar et al.'s paper. And this is how we calculate the direct bias of each data set. Conclusion. Our results are here in this table. This is the first column on the left is the trained models. It starts with the pre-trained BERT model, WNLI, RTE, and so on to MNLI are the glue models or the fine-tuned ones on the pre-trained model from the general language understanding evaluation dataset. And then we have the jigsaw toxicity and RT gender here. The direct bias of each of these models are in the next column, and then there's the accuracy of each of them, and then we have the sizes based on lines and bytes, and how long it took for each of them to run. And before using these ML algorithms, we need to basically evaluate these. Why? Because of what we basically talked about here in this research. And you can find ingredients that are untrustworthy, and basically the data sets that we didn't expect them to have gender bias showed surprisingly higher bias than like a ugly data like toxic. It basically shows that it's like counterintuitive to find out the gender bias in different corpora. So therefore, we need to evaluate those systems with different data sets before using them and making those AIs decision makers in important decision making areas such as like housing, credit score, and hiring. And that's basically our main conclusion and result of our paper that we wanted to talk to you about. Thank you very much for your attention. Feel free to contact us with these email addresses here. We would be happy to talk to you about our research work and answer your questions. And goodbye.